Hey there, geometry students. This is section 8.3, trigonometric ratios and solving right triangles. I'm working on problems 33 through 37 just as examples. I'm not going to go through them all. This is roughly on page 556, and the big concept here is solving right triangles, all the sides and all the angles. So the first problem I want to focus on is number 33. Again, in this problem, it gives you one side length and two angles. We know one is a right angle. We know angle J is 26 degrees. Therefore, we can find angle L because it's 90 minus 26, which is 64 degrees. So I've already figured out the first angle. Remember, all three angles add up to 180. And if one of them is 90, then the two other angles have to add up to 90. So this one's 64. And then I'm going to, just because I was given angle J of 26 degrees, that means that's where I'm standing. So I'm going to stand right here. Boo, boo, boo. There's Mr. Rising. And from this 26 degree angle, I know the hypotenuse. It's 3.2. What side am I looking for? Well, let's start with JK. So I'm looking for JK, and JK is the adjacent side from angle J. So this is, if I'm here, this is going to be the ATJ, this is going to be the OPP, and this is going to be the HYP. So what trig ratio involves adjacent and hypotenuse? Well, that's going to be cosine. So that's going to be JK over 3.2. And basically what I'm going to do here is cross multiply. Cosine of 26 is just a number, just a decimal. I can multiply both sides by 3.2. And when I do that, I'm just going to use my cheater book here. I get 2.88. Now, as easy as that was, in order to find the opposite side, the only thing I really have to change, I don't have to change my position, I could, but let me just use that 26. And again, I know the hypotenuse. And now I'm looking for the opposite side, which is LK. And of course, opposite over hypotenuse is sine. And so now when I multiply the sine of 26 by 32, I get 1.40. If you need to pause that and go back, you can, or also look in your book for other examples. Now in problem 34, they give you two sides and one 90-degree angle. In this case, I need to use inverse trig ratios, or arcsine, arccosine, arctangent, to find my angles. And I can also use the Pythagorean theorem to find any side of a right triangle if I already know two sides. In this case, I'm looking for the hypotenuse. So let's just do it. DF squared equals square root of 5 squared plus square root of 2 squared. DF equals the square root. Square root of 5 times square root of 5 is 5. Square root of 2 times square root of 2 is 2. 5 plus 2 is 7. DF equals the square root of 7. That's pretty cool. Okay, now as for angles, if I'm looking for angle D or I'm looking for angle F, let's just start with angle D. So I'm standing at angle D. I'm going to use my little Greek symbol theta. That's supposed to be a theta. And what I'm saying is, oh, wait a minute. I know the opposite of D is square root of 2. I know the adjacent of D is square root of 5. What trig ratio involves opposite and adjacent? And then you're screaming on your seat here, you're saying tangent. So what you're saying is the tangent of some angle equals the square root of 2 over the square root of 5. How do we figure out what that angle is? Well, you could either use, on your calculator, you could take square root of 2 divided by square root of 5. Let me just do it. square root of 2 divided by square root of 2 divided by square root of 5. And it's 0.6324555, right? And I could actually take this number, I could go down the tangent column of my golden tablet, and I would find 0.63, it's roughly like a 32, 33, 32 and a half degree angle. The other way to do it is to put the arc tangent, to do the arc tangent of the square root tangent of square root of 2 divided by the square root of 5 into my calculator or my phone. And let me scroll over so you can see the very beginning. You'll notice instead of saying tangent, it says arctangent. So I put that value in, and it says it's exactly 32.3 degrees. So really what I'm doing is arctan of square root 2 divided by square root of 5. And that's 32.3. And the book says to round the problem to the nearest degree, so that would be just 32 degrees. So angle D is 32 degrees. Now, I could do the same thing from F. I could do the arctangent of the square root of 5 divided by the square root of 2. Or, since I know I already have a 90 degree angle, I could do 90 minus 32 to figure out that this angle has to be 58. I'm at 6 minutes. Should I stop the video? It would probably make more sense.